Lesson 10.4 is inverses and determinants. Our essential question is, how do you find and use an inverse matrix? So the first thing to look at is the concept summary. So we have a lot of vocab and different things that we need to consider. So the determinant of a 2x2 matrix. So we're only going to be focusing on 2x2 matrices in this lesson. So if this is how we set up our matrix with A, B, C, D, the determinant of matrix A is going to be equal to AD minus BC. And so it says if it's greater than 3. So if we have a 3x3 matrix or a 4x4 matrix, there are formulas to solve it, but it says to use technology to calculate it. So a lot of graphing calculators and matrix calculators, you can find the determinant that way. So the special part about the inverse, which we're going to talk about, is that we learned about the identity matrix a couple lessons back. So if you take a matrix times its inverse, you're going to get the identity matrix. And it doesn't matter. We also talked about how the commutative property A times B isn't the same as B times A, but when you're dealing with inverses, it is. So a matrix A times its inverse, or the inverse of matrix A times A, is both going to give you that identity matrix. So this is what we're going to focus on today. So to find the inverse, you're going to take 1 over the determinant, and then you're going to multiply it by the matrix, but it's kind of mixed up. You can see the A and the D swapped locations, and the B and the C changed signs. So we're going to practice calculating this today with a couple different problems. So the first one we're looking at is, what is the inverse of this matrix? So first thing we want to do is we want to find the determinant. Let's call this matrix A. So the determinant of A is going to be AD minus BC. So that would be 2 times 0 minus 1 times 3. So that'd be 2 minus 3, which is -1. No, sorry, that's 0 minus 3. So 0 minus 3 would be -3. Okay, so then to find our inverse of matrix A, we're going to take 1 over that determinant, so 1 over -3, and we're going to multiply that by, we're going to swap the A and the D, so the 0 here and the 2 here, and then we're going to change the signs of B and C. So then if we multiply that through, we get 0, 1/3, 1, and -2/3. So this would be our inverse of this matrix. And so we could check that by multiplying them out, and we should get the identity matrix. And just to remind you, the identity matrix has the 1s in the diagonal and 0s everywhere else. So if we multiplied matrix A by its inverse, we would get that. Okay, example 2 is just two more practice problems of this. So to find the inverse of A, we're going to take 1 over 4 times 2 minus 1 times -1. And then we're going to multiply that by 2, -1, 1, 4. Okay, so if I get the determinant, it's going to be 8 minus -1, so 8 plus 1, which would be 9. So this is going to be 1/9 times that matrix. So if I multiply that out, we'll do this in one step here. So if I multiply that out, I get 2/9, -1/9, 1/9, and 4/9. Okay, so then part B, before I go through this whole example, sometimes it helps to calculate that determinant first, because in this case, we can look at, if I take 6 times 4 minus 8 times 3, I'm going to get 0. And we can't take 1 over 0, which is part of our formula for finding the inverse. So that means that we can't find the inverse. There is no inverse of b because the determinant is equal to 0. So sometimes it helps to find the determinant first, because if it is 0, we can't go any further. Okay, so our next problem, we are going to look at finding the area of a triangle defined by vectors 3, 4, and negative 1, 2. So on this one, we are going to first look at kind of how we would set this up. So if I have, I'm going to do a sketch here. So if I have two vectors, so I'm just going to call this vector AB and this vector CD. We can set up a matrix with those points. So if we call this matrix T, we can make it AB because we put the X and the Y, and CD. So what this is going to do, combine with this formula up here. So the area of a triangle is going to be this formula. So if we look at this with the vectors that we're given, so we're given vector 3, 4, and negative 1, 2. So for my matrix T, I'm going to have 3, 4, and negative 1, 2. So what we're going to do is we're going to take the equation that we have up there. So the area of T, so the area equals 1/2 times AD minus BC. So that would be 3 times 2 minus negative 1 times 4. And basically that's just taking 1/2 times the absolute value of the determinant of T. So if we look at this, we're going to get 1/2 times, this is 6 minus negative 4, which is 10. So 1/2 of 10 would be 5. So that tells us that the area of this triangle defined by those vectors is 5. Our last example, similarly, is we are looking at how do we find the area of a parallelogram with one vertex at the origin defined by these vectors. So since a parallelogram is just two triangles, we know that the triangle was 1/2 of the determinant. We know that the parallelogram area is just going to be the determinant of matrix T. So again, we're going to make a matrix T, which is 5, 7, 2, negative 5. And we can find the determinant of that. So we can do absolute value here of 5 times negative 5 minus 2 times 7. So we get negative 25 minus 14, which is negative 39, but we're taking the absolute value because we also know that area is not going to be a negative value. So our area of our parallelogram would be 39 square units. Okay.